Okay. Welcome back from the break. I hope you enjoyed your break. I hope it was good. I hope it was restful. I hope it enabled you to catch up with some rest and also with some work. Having said that, let's move on with today's topic. Okay. Um, Please take note that there's a recording going on, and this is for the benefit of those who may not be able to attend. Today's topic is going to move us away from regression analysis. We are going to begin to talk about index numbers. Okay, index numbers are very important in statistical analysis because it enables us, the index number enables us to make comparisons between periods and also comparisons between, you might say, different members of a group. But it helps us to also reduce numbers to what you might call value-free kinds of numbers that enables you to make comparisons between, again, members of a population or time periods. All right, so what is an index number? I'm going to pull up a PowerPoint, set of PowerPoint slides, and I'll use these PowerPoint slides to compare, to illustrate what we do with index numbers. All right. All right. Now, like as I was saying, index numbers help us to make comparisons, but it is actually a measure of relative values. It's a measure of relative values. Okay, how does one number compare to another one? The examples of index numbers are, price indices, like a consumer price index, a producer price index. You have also things like an import price index. And also you have quantity indexes, and you have a quantity index, okay? And so if you do research in economics, you deal a lot with index numbers, okay? So now what would be our objective at the end of this? And we're going to be dealing with very simple kinds of index numbers. And so we're going to be able to compute and interpret simple index numbers and also unweighted index number. That's a simple unweighted index number. We would also be able to compute and interpret unweighted aggregate index. So there are simple unweighted indexes and also something called aggregate indexes. And then we would also compute weighted aggregate index. And then aggregate index is one thing, and then a weighted aggregate index is another. And we would also then illustrate, say, consumer price index and its implications. And you hear about computer price index every day, CPI. The CPI is used as a measure of inflation. And you hear about inflation every day. Something that you bought last year, an apple, that you bought last year for 50 cents, this year you buy it for 55 cents. Okay, but it's the same one apple. It's not like there are two apples. And so you calculate an index of price of apple comparing last year to this year, comparing this year to next year. So these are examples of indices. Okay. Like we say, it can be used to compare two numbers, a number that measures the relative value or the relative change in price, in quantity, in value to another period, or between two what do you call it, members of a population, like countries, cities. You can compare. You can calculate indexes comparing New York to San Francisco. Okay, you can create an index comparing China to the United States, and I'm going to give you provide you illustrations. Okay, and so and a simple index simply compares two numbers or measures the relative change in just one variable over time. And I'm going to provide you an illustration. All right, so I'm going to move from here. Just give me a minute. Let me be sure what we're doing. I'm going to take this off for a minute. Okay, bring this back. Okay, so now we get back to where we were. This is an example of a simple index. Okay, look at three variables: capacity, salary, wins by a sports team, an athletics team. The capacity, for example, to produce, say, the capacity of a stadium. Okay, and so we are comparing here. Let me be sure. Can you see this better now? Hello?
Yes.
All right, right. Okay. So we are comparing, say, the stadium capacity for Arizona, Atlanta, Baltimore, the Red Sox, Chicago, White Sox, their stadiums, okay? And so what we do is we choose what you call a base. We choose a base value. For example, here we use Arizona as the base. Okay, we use Arizona as the base. It could be a member of a population like Arizona, and we choose Arizona as a base. It could be a time period. You can choose 1960 as your base. So this is how indexes are calculated. So we choose a base, and the base is Arizona. And so we compare the capacity of Atlanta, Baltimore, Red Sox, Chicago, White Sox, and any other location that we want to add, and compare them to Arizona. And so we simply divide Arizona by Arizona, then we divide Atlanta by Arizona. As you can see, if you divide Arizona by Arizona, you get 1.0. If you divide Atlanta by Arizona, you get 1.2, which means that Atlanta has a capacity that is 2% more than that of Arizona. And then we see Baltimore. We divide Baltimore by Arizona, we get 0.95. That simply means that the capacity of Baltimore Stadium is only 95% of Arizona. And so we do for Red Sox, we do for Chicago, and we do for White Sox. So this is a very, what we call a simple index, okay? It's a very simple index that simply takes a base and then we divide the values of the other locations or the other units or the other members of the same population, it could be a time, by the base, and simply enables us to compare one value to the other. When it comes to salaries, okay, if we say the Arizona salary is the base, we divide Arizona by Arizona, and we can see that Atlanta average salary is 12% more than higher than Arizona, but Baltimore is 10% higher, and Red Sox is 2.33 times that of Arizona, and so forth and so on. All right, so now we can, of course, the interpretation here, for example, the population of the Canadian province of British Columbia in 2013 was 4 million, and for Ontario, it was 13 million. What is the population of British Columbia compared to Ohio? All right, and so we simply take the population of British Columbia, 4 million, and compare it to Ohio, and we simply say, multiply by 100. So British Columbia's population is only 34% of Ohio. I mean, of Ontario, not Ohio, Ontario. Okay, so again, this is an example of a simple index. Now, this might appear trivial to you. It is not trivial if you have numerous other members of this population. Then an index simply, when you calculate the index and put it in a table, like we have here, suppose you have 20 of them, it becomes easier to look at the other members of the population and have a quick and easy interpretation of the relative values to the base, okay? And here, the population of Ontario is the base, but then you could have had 20 other cities, and then you make that comparison. Okay, well, again, this is just an illustration of the simple index that we calculated. And you can, of course, plot the index on a chart. It makes it easier. And again, by reducing the values to indices, it makes it easier for you to make a chart that does not, reduce things to, say, at the bottom of the chart. And you can make a lot of comparisons. I think I did something recently where I could also illustrate you the difference between using an index and using regular values. All right. Now, we can go beyond this and then have what we call aggregate index, okay? Aggregate index. And I will illustrate an aggregate index for you. All right? Now, you can now look at, say, a basket of goods that we consume, okay? We have bread, we have eggs, milk, apples, orange, and coffee, okay? And so we ask ourselves, for you to consume this basket of goods, what would you spend between this year and the following year? Okay, what is the relative price between one year and another, okay? And so you simply add up the prices, okay? Add up the prices. For example, if you look at 2003 and 2013, you're comparing two years. And so you compare the price, you calculate a simple index of the price between 2013 and 2003. When you divide 1.422 to 1.042, you get 136.5. Okay, and you calculate 1.933 to 1.175, you get 164.5, and then you get the sum of these indices. Okay, you get the sum of these indices and divide by 6. There are 6 items here: 1, 2, 3, 4, 5, 6. Okay, there are 6 items there, and so you divide. Just a minute. Excuse me. Okay. Not yet. Okay, there are 6 items here, and so you divide the sum of these simple indexes. You divide the sum of these simple indexes by 6, because there are 6 items here. And so you say, on average, the price of these 6 items increased by 52% from 2003 to 2013. So,
Professor,
again,
quick question.
Yes.
All right, you see, for example, where it says bread, it says the simple index is 136.5.
Yes.
Why isn't it just 1.365 like in our other example?
Remember that you can multiply them. In fact, you multiply them by 100. This is why it's 136.5. If you think, let's get back. Let's go back, because it comes to the same thing. You can see here we multiplied by 100, so that it gives you the percentage value right away.
Okay.
Okay, it gives you the percentage value right away, but you don't have to do that.
Okay.
All right. You can see here I multiplied by 100. 1.0 times that, that's 100. And if you look at an index, okay, here again, we still multiply by 100. So you can see that they multiply by 100, but over here, we did not multiply by 100. You get it?
Yeah.
Okay, we did not multiply by 100, and you can use that. You can use the simple values, and you don't have to multiply by 100.
Okay.
All right? Okay. All right, so this is what is called an unweighted aggregate index. Okay, you don't weight by quantities. Okay, and so you don't have the quantities here. You simply take the sum of the price indices and divide by the number of items. Okay, and the choice between a weighted and an unweighted index just depends on how quickly you want to get a result, how uncomplicated that you want your result to be. And so you can do something very simple. Okay, but again, they have consequences for the kind of analysis you want to do. Okay, this is the same old thing. All right, now there's another way to calculate an aggregate index. Again, this is an unweighted aggregate index. So you can compare prices directly, okay? For example, in 2003, you bought bread white per pound at $1.42. I mean, $1.04, okay? And then you take simple indices. Okay? This is the sum of the price in 2003. Summation P naught. Now, P naught is P sub 0 is the price at the base. Okay, and here 2003 is the base. And you add up the prices. For example, you bought 1 pound of bread at $1.04 in 2003, and in 2013, the same 1 pound of bread, no more, you bought it for $1.42. All right, and you can go on and on until you have, if you have this basket of goods consuming a dozen eggs, a gallon of milk, 1 pound of apple, 12 ounces of orange, and 1 pound of coffee. These are the prices that you bought them at in 2003, okay? And you simply add them up. This is unweighted. This is unweighted, okay? So in 2013, the very same items you bought for the prices that are listed there, you add them up, just add them up. And then you divide the price of one period by the price, the sum of the prices for the base period, and you get 156.1. That means that the data shows that the price of these 6 items increased by 56.1%. Okay, by 56.1%. Okay. All right, here's an example. Okay. We have the same thing here, and you simply divide 6.8 divided by 4.9, and you get an index out of that. Now, we come to weighted aggregate index. And there are different kinds of weighted index, okay? And we are, like I said, we are doing very simple indexes. There can be more complex indexes. And so now you have weighted indexes, okay? The weighted index enables you to compare, say, costs or prices from one period to another based on the importance of each item, okay? The importance of each item. And you say to yourself, let us think about if you were thinking about, say, your living expenses, okay? So during the year, you compare, you live on 5 pounds of bread, 6 pounds of eggs, or 6 dozens of eggs, and so forth and so on. So now you ask yourself, in order to live this year, in order to live today, compared to how you lived last year, consuming this combination of quantities, or even a different combination of quantities, what would it cost you? Okay. So we have what we call the last payer's price index. And you compare the price today, what would it cost you today to consume the quantities of last year? So you look at the price today times the quantity last year, divided by the sum of the price last year and the quantity of last year, okay? And so you ask yourself, suppose you stuck with your combination of last year. What would it cost you today to have that combination? And so now we have, say, 2003 and 2013. So the same basket of goods. We're looking at the same basket of goods. Now, remember, we have not changed our basket of goods. But now we are asking ourselves, or we are taking into consideration that we just did not consume 1 pound of bread during last year, 1 dozen eggs last year, okay? Because what we did previously, we simply said, if you were to consume only 1 pound of each of these, what would 1 pound of each of these cost you or what would 1 unit? Let's take a unit of measure, because eggs you consume in a dozen, okay? And milk you consume in a gallon, okay? But you do not consume 1 gallon. You're just asking yourself, 1 gallon of milk cost me $3 last year, but this year it's cost me $3.50. Okay, so what would 1 unit of each of these compared to last year, what would it cost this year? But when you're looking at a weighted index, this weighted aggregate index, what the weighted index is saying, let us say that you consume a basket of goods consisting of different quantities. That is the combination of these goods that enable you to live the way you want to live. And so what will it cost you today compared to what it cost you last year? Or what did it cost you this year compared to what it cost you 10 years ago? Where 10 years ago would be your base. Okay? So in this year, in 2003, you consumed 50 pounds of bread, 26 dozen eggs, 102 gallons of milk, 30 pounds of apple, okay? 40 12-ounce units of orange juice, and 12 pounds of ground roast coffee. That's what you consumed in 2003. But in 2013, you consumed different set of quantities. So, and there are two ways, okay? Let's go back one step. Okay, so you can look at the price today of what you consumed in 2003 and say, what would it cost you in 2013? So you're going back to your quantities. So you're comparing, if you maintain this standard of living or this combination of living items, what will that combination cost you in 2013? You are not looking at the quantities of 2013. You are looking at the quantities of 2003. What will it cost you today? If you look at the standard or the combination of goods, the way you combine your goods, if you were to combine those goods in the same way, okay? So let's now look at how to compute the last payers index, okay? Now, so you take the price today of what you consumed last year. So the price today of 50 pounds of egg would be totally different, okay? Which is, you take 1.422 and multiply it by 50, not by 55. We didn't get there yet. We're going to get to that point, okay? You take 1.422 and multiply by 50, okay? And you take 1.933 and multiply by 26, okay? So this is, and I need for you to verify by yourself. Verify that by yourself, multiply 1.422 by 50 and see what you get.
I got the 71.1 or 0.10.
Okay. All right. This is 52.
I got the
Okay,
same
you
number.
get 71.1. You see that there? Do you see it?
Yes.
Okay. So now you add up those multiplications and you get 692.77. Okay. So if you were to consume your last year's quantities at today's prices, this is what you get. You get a sum of 692.77. Okay. And then you say to yourself, you take 1.042 multiplied by 50, you're going to get 52.1. Am I correct? Hello? Multiply 50 by 1.042. What do you get?
52.1.
Okay. You get 52.1. So you can see you create two columns. The column that multiplies last year's price by last year's quantity, and then last year's quantity by this year's price. All right, and you get that. And when you divide 692.77 by 493.86, 692.77 divided by 493.86, what do you get? You get 1.402. You get that? Hello?
Yes.
That's what you get. And multiply it by 100. You get 140.276. Now, like I said, you don't have to multiply by 100, okay? But we do that so that we can get a direct percentage. So based on this method, the price of the 6 items increased by 40.28% between 2003 and 2013. What it simply says is, if you maintained your standard of living or your style of living in 2003, what would it cost you today? What would it cost you in 2013? This is what this actually, the information that the last pairs gives you, okay? Now, we then have the alternative, okay? We have the alternative called the PASH index, okay? The PASH index. Okay, so the PASH index looks at today's quantity compared to the base price. Today's quantity, or the quantity at a particular point in time compared to the base price, okay? Which is simply says, if you were to buy things, what your new standard of living or your new style, it's not a standard, it's a style, you know, in the sense that the fact that you change the quantities does not mean that your standard has improved. It just means this is the style that you have chosen, okay? So you take the price of the particular year times the quantity of that year and say to yourself, you know, what did it cost you, or what is it costing you compared to what it would have cost you in the previous time, all right? Okay, so we take the price of 2013 times the quantity of 2013, and then we take the price of 2003 to the quantity of 2013, all right? And we do the same thing, and what do you get? You get 138.9, okay? Which means that based on the PASH index, the price of these 6 items increased by 38.9%, okay? Which is to say, now that you are asking yourself, if you had consumed the 2013 quantities at the 2003 price, what was the difference in the cost of that particular style of living? Your new style, not your old style, your new style now, okay? If you had based your living on your new style, what would it have cost you in 2013, in 2003 compared to 2013? You can see very clearly that still your new style has cost you more in 2013 than it would have cost you in 2003. So you say your new style or this particular basket of goods cost you 38% more, or 38.9% more, which is actually nearly 39%. Now, in an attempt to to essentially each of those two methods, the Pash index and the last payers index, they have their own biases in terms of what information they provide you. And so we have more like a geometric mean of the last payers and the Pash index, in a sense, to be able to make what you might call an unbiased comparison. So we have what we call the Fisher's ideal index. The Fisher's ideal index simply takes the last payers index and takes the Pash index and get a square root. Okay? Get a square root. And so we take the 140.28 whatever times the 138.9, and we get what do you call it? We get the Fisher's index, and you can see that the value of the Fisher's index is actually a combination of, it comes somewhere in between, comes in between the two indexes. One is 138, one is 140, and we get a square root, and we get 139. And 139 is less than 140, but higher than 138. And so, based on the Fisher's ideal index, the price of goods, your style of living, has increased in cost by 39.6%. Okay. All right. And there is also the value index, but I'm going to skip on that, but there's nothing difficult about using a value index. Okay. It looks at, it takes a summation of today's price and today's quantity and divided by the base price and the base quantity, the summation, and so you get a 17.8% change. Now, the Dow Jones Industrial Average that you hear about every day, it's a simple index. Okay? No big deal. It's a simple index. It does not, it's not based on weights. The Consumer Price Index is, what I want to talk about, because we hear about it every day. The Consumer Price Index enables you to determine the effect of price increases. And you definitely learned about the CPI, the nominal income, nominal values, market values, and real incomes and real output. Well, here it is. This is how they compute the CPI that you learn about in Econ 200 and in Econ 309, which is microeconomics, and wherever is in money and banking, you hear about inflation. Well, this is how you calculate it. Okay, you start from the CPI. So you take the CPI of this year and subtract it from the CPI of last year and divide by the CPI of this year to get the rate of inflation. Okay. Now, what's the importance of that? Okay. The CPI enables you to calculate real income. What is the real? Suppose your salary this year is $10,000 a month, and your salary next year is $15,000 a month. Okay. Now, what if prices have increased by 50%? That means your real income did not change. Okay. Your real income did not change. And I'm going to see if I can use a very simple example to illustrate this point. Okay. I'm going to do a calculation so that you can see what we mean. Now, suppose your income, your annual income was $20,000 in 1982. And today, the next year, 1983, your income is $40,000. But the consumer price index was $100 this year, and 100 this year and 200 the next year. When you come to look at it, if you multiply 20,000 by 100 and you multiply 40,000 by 200, you can see your real income did not change, because with your $40,000, you would only be able to buy the same things that you bought last year. So your real income has not changed, okay? So if you bought one apple this year to eat, next year your income has doubled, but you will not be able to buy two apples. You can only buy one apple because the price of apple has doubled. All right. You also have a producer price index, which is the index of prices that producers, manufacturers use, they face. Okay. And again, this is a simple index here. The PPI, the base is 1982. This is just what do you call it? Simple index of output, okay, or the cost of materials. Okay, so if you take sales, for example, of $875,000, and then the sales, different sales in different years, and then you have the producer price index using 1982 as a base, and you can see the way the PPI has changed over time. What is the value of output in constant dollars? And you can use any particular year as your index. It could be 2000, it could be 2004. You can use any year as your base, okay? And so in current dollars, okay? In current dollars, of course, if you divide 875 by 875, so this is your, the value of output. Oops, excuse me. Okay, the value of output is 875. Now, even though in 1995, your sales came to 1.482 million, but the PPI, the price index was 127. So your real value of sales, your real value of output, whatever you want to call it, is actually 1.158 million, not 1.482 million, as is indicated here. But as you can see, the PPI kept going up over time. So in as much as the sales increase over time, you can see that the real value of the sales is declining. It's not increasing because the PPI has been escalated. Okay. All right. So, well, this is, like your homework data sets that I asked you to do. And you simply use 1950 as your base, and PPI is there. And so let me see if I can pull up something that I did recently. Okay, I'm going to pull up the file. Are you able to see my chart?
Yes.
Okay. All right. I'm going to, are you able to see this other chart?
Yes.
Okay. Now you can see I plotted the same values, okay? Except that the chart that you see here, you can see the flat blue line, right? You can see the flat blue line.
Yes.
Okay. You see the flat blue line values, the price of oil and exchange and inflation in a country, in Pakistan. It's based on a paper that I presented recently, about a week ago, okay? And so I looked at the price of oil and the rate of inflation. You can see the blue line is flat. You can see that?
Yeah.
Very good. Now I'm going to present the same chart. You can see that the blue line is higher up. You see that?
Yes.
Okay. Now the simple reason was that I converted the values in the previous chart into indexes. And so that sort of like brought the values to look similar. I looked at an index of oil prices and an index of inflation instead of using oil prices and inflation, because oil prices could be high. It could be like $50, and then it could be $10 today, it could be $50 tomorrow, it could be $30 another day. And then when you compare that to inflation rate, which are small numbers, like 10%, 8%, 12%, and so what have you, so one line became very flat. This line became very flat, and the yellow line gyrates and is very high. But when I converted both sets of values to simple indexes, I was able to make the comparison clearer. And the simple idea that I wanted to point out in doing the chart, I wanted to show that as oil prices increase, the yellow line is oil prices. As oil prices change, also inflation changes. But you can see it's easier to see that connection between oil price and inflation by converting the oil prices to an index and inflation to an index. You see the difference? Even though
So generally speaking, I'm sorry, generally speaking, if we're going to look at indexes, it's better to compare indexes to indexes.
Precisely. Especially if you want to do a graphical illustration like I'm doing here. It's better to compare indexes to indexes rather than numbers to numbers, because some numbers could be large. Some values could be large. For example, oil prices could be very large from one period to another, like $10 today and $20 tomorrow and $40 the next day. But indexes will remain, with very low values. And in as much as the oil price, affect inflation, and as you can see, the whole idea is to show that when inflation goes up, if you look at inflation goes up here, if oil price goes up here, then if oil price goes up here, inflation goes up. But you'll not see it very clearly if you plot the values. But if you plot the indexes, you can see it's clearer what you're trying to illustrate. See, like at the beginning here, you can see here, oil price goes up, inflation also goes up. But if I do it on this other chart, you can see the relationship is very clear. And sometimes it's even better to use it to do a regression analysis, depending on what you're trying to achieve in terms of parameters of your regression. But, you're not at that level yet. and maybe you'll be there someday if you choose to pursue statistics a little bit more. It might even be better, and I have done it quite a bit when I'm trying to look at the connection between, say, prices and quantities. When I'm trying to estimate a demand function on a time series and over so many years, I prefer to use price indices to compare to quantity indices, because the quantity indices are real and the price indices are real, as opposed to the nominal values of prices. Especially if my objective is to calculate elasticities. You get the idea?
Yeah.
Okay. All right. That does it for my lecture. Do you have any questions for me?
Nope.
All right. Okay.
Yeah, I have a question for you, Professor, but it doesn't pertain to the class.
Okay. All right.
Yes, I have questions as well, Professor.
Let me just show you one more thing. Okay, so this is the paper that I was talking about. Okay. All right. And I'm going to illustrate the point. Okay, so you can see this chart that's big there, and you can see the flat lines below it. When I go to the next, you can see it's easier to make the comparison between the various charts, between the various values, oil price and inflation. And if you when you do it on this chart with just absolute values, you can see it becomes very difficult to actually illustrate your point. You get the idea now?
Yes.
Okay. All right. So what was the question you say you had? Is it something that you don't want others to hear? I will dismiss the class and you can ask your question.
Yeah, sure, you could dismiss the class. It doesn't pertain to the class.
Okay. So everybody else then can leave. Okay.
All right. Have a good evening.
All right then. Enjoy your evening. I'm going to stop the recording.
I also have a question.